Would love to see some faces. If not, that's okay. So, perfect. I see Franklin has turned on his camera. Amazing. Okay. Everybody, looks like we're doing great. So I'm going to share my screen. We have some fun stuff planned for today. So I'm not sure if you guys have seen it, but I have posted on the Google Classroom a review sheet for all of you to look over. So this is basically just a shortened
review sheet.
Oh, Jaden has joined. Amazing. So yeah, I've added a review sheet on our Google Classroom, so you guys have somewhere to reference to for everything that we've learned so far. So instead of posting, we've learned up to 60 slides, you have it all condensed into this awesome review sheet. So if you ever forget something, feel free to refer back to that. Has anybody had a chance to take a look over the homework?
Yeah.
Yeah, awesome. Okay, this week's homework was fun. We did this homework in class last week. So let's quickly take up this homework. So it's just a nice introduction to loops. So who would like to help me out with the very first question? So all we have to do is we have to tell this little character how many times it has to loop going up and how many times it has to loop going to the right. In this case, you only have 2 commands. So who can tell me how many times? This one's pretty easy. Go ahead, Kathy.
2.
So we're going to loop twice what?
Of that code.
So if we loop it twice, he's going to go up, right, twice. That's it. So we have to tell him how many times are we going to repeat going up and how many times are we going to repeat going to the right. So if we have a loop, let's say our loop is this. So in this case, let's do this one, or let's see the first one together. So in this case, he's going to have to repeat it 3 times, right? He's going to have to go to the right, then down, then right, then down, then right, then down. So that's 3 times. So in this case, he's going to have to go up 3 times, then to the right 3 times, and up 3 times, and then to the right
3 times.
So yeah, exactly. So we're going to loop basically 3 times. So that's the first one. Does that make sense with everybody? Awesome. Let's try the second one. Who would like to help me out with this one? Jaden, help me out with this one.
So you loop upwards 2 times.
Yeah.
And then you go right 1, 2, 3, 4, 5 times.
Twice. Oops, I can't spell. Up twice. Then we're going to go to the right. How many times did you say?
5 times, I think. I don't know.
Right. 5 times. 1, 2, 3, 4, 5. Yep. Then what's my next step?
And you again loop 2 times. No, 1 time. Wait, what?
We go up once, and then how many times are we going to the right?
2. No, 3.
3. Right. And then up
Okay.
once, and then 2, right? So this is how we would, if we were to do right, for example, 5 times, so right, that would be very, very long. It would take a while. Let's say this was 10 rights or 20 rights. So we can put that into a loop. So that's essentially what they wanted us to do. Let's take a look at the next one. Franklin, would you like to help me out with this one, the bottom one over here? You can guide me. How do I get the football to the...
So go to right.
To right.
Okay, repeat that. Then go down.
2 down, perfect. And then we're going to repeat that, right?
Then go right.
Yeah, but we're gonna, so see, we have a pattern here. Franklin is pointing out a pattern. We're going 2 to the right, 2 down, right, down.
Not 2
right.
down.
Yes, sorry, 1 down, 1 down, 1 down. 2
no,
right,
you
1
have to go 1 down.
Yeah.
You could just write down.
I wrote down right over here.
Then go right, then down, then right, then down.
Right, down, you're right. There we go. Right, down, right. So I think we're at the bottom. So 2 right, down, right, down, right. We have 1 more down. And then how many times am I going to go to the right? I'm all the way here.
Go to the right. Okay. Right. 5 times.
Times, okay. And then
Then go down 2 times.
down just once, right? To get down to the start. Just one down.
No, that's not going to the start. 1, you're still not reaching
Right.
the start. 2, down.
Okay, we could say that. Down 2 times, sure. Perfect, there we go. So we see we have multiple opportunities that we can use loops, especially this long area over here where we're gonna go to the right 5 times. So that's where we would use the loop, and that's where they become very, very, very handy. We're not gonna do this part. This was just for you guys to just practice on your own. Today's class, we're going to continue with if statements. We're gonna do a quick review, do some coding with if statements, and then we're gonna learn about something new. We're gonna learn about lists. So if anybody has any questions about the homework, now would be a good time. If not, I'm gonna move forward, okay? Sounds good. Okay. Where is that? I think we have a new student today. I believe Austin. We can say hi, Austin, to all together to make him feel welcome. And then we're gonna get into conditional statements.
Ask Austin how old he is.
Hi, Austin.
Hi, Austin. Very nice of you all.
Hello.
Hi, Austin. And we'll make him feel very welcome.
Hey, Austin, how old are you?
Maybe Austin doesn't want to answer. That's okay.
As input.
Okay, great. Austin, have you done coding before?
Yeah,
Yeah. Okay. So you're familiar with conditional statements?
I know.
No? Okay, great. We're going to be learning about that today. Okay. So who can tell me before I go to the next slide, what is a conditional statement? Ryan, you know what a conditional statement?
Conditional statement is a statement that is conditional.
Exactly. It's very simplistic, I would say. It's in the name itself. So conditional statements, like Ryan said, it's just a condition. And we check if a condition is true. If that condition is true, then we do something. We perform some sort of action. So we use a condition to decide whether some sort of action is executed or not. So if that condition is true, in this case, this is my favorite example. If I am hungry, that is our condition. We're checking if something is true. If that's the case, then I will do something. So we're gonna do a quick review, a little fun activity. If you like sweets, so this is me creating an if statement. If you like sweets, so that's chocolates, ice cream, anything sweets, touch your nose. I see Franklin is touching his nose, Ryan. Nathan, you don't like sweets? Okay, so you're touching your nose, beautiful. Okay, next one. Who would like to create an if statement for this example? So you could probably create an if or else. Kathy, go ahead.
If you like bananas, tap your head. If you like apples, rub your belly.
I love bananas, I love apples, so I'm tapping and rubbing
Monkey.
my one.
Monkey.
Awesome, really great job, Kathy. That was a great if statement. Perfect. Who would like to do the next one? This is people dancing. Who would like to give this one a go? Franklin, go ahead. You could create an if-else statement.
Okay. If you dance well. Okay, so if you dance well, turn around. If you cannot dance well, then put your hand in your mouth.
Hand in your mouth. Okay, maybe we can touch your mouth.
No, put your hand in your mouth. Like this.
In your mouth? Maybe we're just gonna just touch your mouth. Maybe your hands aren't clean. Especially now.
I'm gonna put my finger in my mouth, but not touching it.
Yeah, that's a great option too. Perfect. Okay, so we have a couple dancers in here, a couple here who can't dance. That's great. Awesome. Who would like to do this one? Nathan, try this one.
Oh.
This is Lego.
If you like building with Lego, tap your head. If you don't like building Legos, touch your ears.
Amazing if statement. Really great job, Nathan. That was a great if statement. Perfect. So those were all really great examples of if statements. How we can form these
I
simple.
like that pirate ship guy.
The pirate ship guy, yeah, that one's really cool. There's a lot of things you can build with Legos. So great if statements, everybody. So now let's take a look at some code. So how do these examples look like in code? So let's say we have a Boolean. Tired is a variable. We stored a true inside this variable. And we're saying if tired. So this is a new keyword. We haven't seen this keyword. So we were always using these equal signs, right? But there's a new keyword that we can use. This is only specific to Booleans. You can only do this if it's a Boolean related question. So if tired was a string, we couldn't do this. So keyword is only specific to Booleans. Otherwise, you're going to use the two equal signs. So if tired is true, so this sounds a little bit easier to say instead of if tired equals true. So if tired is true, that's going to check if the tired variable has the same value as true, the Boolean, print, I will go to sleep. So in this case, will the statement be printed?
Yes.
Exactly. Good job, Jaden. What happens if I change it to false? Kathy, will this statement be printed?
No.
No, right? Because it's false. Tired isn't true, so it won't be printed. Great job. Let's take a look at some other examples. We've done this example before. Franklin, let's say I have this variable 8 veggies is equal to true. I say if 8 veggies equals to true. I could also use the keyword is, but in this case, I'm showing you two different options. So if 8 veggies equals true, so we're checking for equality. Print, you can play your favorite game. Else, print, go to bed early. Franklin, which statement do you think will be printed to the console?
So, okay, so if you eat veggies, you can play your favorite video game. Else go to bed early. So, and if you like it, so you can play your favorite video game presented to the console.
Exactly, and why is that?
Because many people like veggies.
Yes, but also because 8 veggies is true, right? It happens to be a true condition. So it's going to check this one first. It's going to say, yep, it's true. So I'm going to come here, and it skips the rest of the statements below that. So if I were to change this to false, you guys guessed it. It's going to check the first if statement. It's going to say, no, 8 veggies isn't true. So it's automatically going to go to the else statement. And the else statement doesn't need a condition because it's like an automatic catch. You can almost think about it that way. You never need a condition for the else. It's going to automatically happen. It's like a safeguard. If none of the above is true, then the else will be like the last resort of what's going to happen. So print, go to bed early. Let's take a look at this example. So let's say I have two variables. Nathan, you'll help me out with this one. Is summer is equal to false and can swim is equal to true. If is summer is true and can swim is true, print I will go swimming. Else, print I will not go swimming. Which one of these two will be printed? I think you're
I
muted.
will not go swimming since is summer is false. But even if can swim is true, it's not summer, so you'd either have to swim in the freezing pool or just not swim.
So the second statement will be let's say I were to change the and into an or. What's going to happen now? Jaden, what will happen now?
Wait, what was the question?
So if I changed, instead of the and, I had an and there before, I changed it to an or. What will happen now? Which of these statements will be printed? If I change it to an or, if summer is true or I can swim, I will go swimming.
If summer is true. I'll go swimming?
Yeah, exactly, because is summer is false, but or, we learned or statements only need one of the conditions to be true. So in this case, can't swim is true, right? You can see up top here. So we're good to go. So we'll probably be swimming in very, very cold water, but that's okay. Let's do a quick activity before we do some coding. So you guys, if you have a piece of paper or if you can remember it in your head, we're going to do a little activity. So you're going to come up with a rule, something that always happens. So maybe like, I always go to school on Mondays. Then you're going to come up with an exception, also known as a condition. So to the specific rule. So let's say if it's a holiday, then I don't go to school on a Monday. So you're going to make an exception to your rule, per se. And then you're going to repeat this process 3 times. And then we're going to share one each. So take a couple minutes. I'm going to come up with one as well. Let's have it done or you guys can let me know. You can raise your hand once you're done your 3 condition statements. That way we're practicing with coming up with conditional statements. Does everybody know what we're doing?
I have a question about the last one.
Yes.
Repeat, like making this, we make 3.
Yes, so you're gonna make 3 statements.
Wait.
2 or 3. We can make 2 or 3, how many ever you want to come up with. And then we're just all going to share one.
Battery.
Okay, has anybody got at least 2 conditional statements?
Yeah, I have 2.
Okay, great. Jaden has 2. Nathan, do you have at least 2? Franklin, do you have 2? Ryan, how's that going? Take your time, no rush.
I do have 2.
Amazing. Okay, let's start sharing. Kathy, do you have at least 1 or 2?
I have 2.5.
Perfect, that's great. Awesome. Jaden, would you like to share first?
Okay.
Let's share 1.
I have 3 now.
Amazing.
I use my computer to take classes.
So that's your rule. What's an exception maybe to that rule?
If my computer is broken, then I can't take classes.
That is a great conditional statement. So I always use my computer, but I don't if my computer is broken. Great job, Jaden. Kathy, would you like to share a conditional statement?
Yeah.
Go ahead.
So the rule is when it's not raining, I will play. The rule is I play outside every day. If it is raining, then I don't play outside. Else, I will play outside.
Great job. I love it. Amazing job. That was a great conditional statement. Nathan, go ahead. Okay, we'll give Nathan a moment. Ryan, would you like to share a conditional statement? We'll come back to you.
Okay. If it's 9:30, I go to sleep. And an exception is if it's a weekend or a holiday or a sleepover, I can sleep late.
That is a great conditional example. You came up with a rule and an exception to that rule. Really great job. Let's see who's next. Ryan, would you like to share a conditional statement?
Yes.
Go ahead.
Okay. I brush my teeth every day. If I'm sick, then I don't brush my teeth.
Yeah, we're probably very, very tired and you want to sleep all day in your bed. That is a great conditional example. Thank you very much, Ryan. Franklin, go ahead.
Okay, so I came up with 2,
Yeah, go ahead.
wait. So I can't examples like if I did homework, then I don't have to do any more homework.
That is a great conditional statement. Your rule is I do homework. Let's continue with, so we just did our activity. Let's continue with some coding. So I'm going to go back on Code Collab. I'm going to copy the link. You guys know how to use this. I'm going to share the link in the chat. And I'll create, okay, there we go. So it should be in the chat. And we're all going to go to our file. So you have a file for your name. So just go into the file, make sure you're in the correct file with your name. So just select the one, you can double click it and it will take you to your file. And we're going to do some if statements. We're going to try to do this. We'll try to finish this up by 7:25, and then we're going to learn about lists. So we're going to spend a little bit of time on conditional statements. We've done a couple of exercises before. So is everybody in their files, or does anybody have any issues accessing them? Let me know.
I don't see my file on there.
Austin. Oh, yes, I'm going to create a new file for you. Thank you for letting me know. I thought it was missing. Okay, we're going to create one for you, austin.py. So here you go. So I'm just pasted into your file. So if you just select your file, you should be able to see all the code. So let me know if anybody has any issues or they can't see any of the writing in their file. If not, we're going to do the first one together. So I'll show you guys how to do that. And then we're going to spend a couple minutes. You guys are going to all finish off and then we're going to take it up together. So the first one, we'll do it together. So you're going to write an if statement. So in this case, if num is smaller than 100, you're going to print this number is small, else print this number is big. So we don't touch this code here. We're going to write our code here. So I'm going to start off with my keyword if. I'm going to say if num is smaller than 100. So this is a symbol to check if it's smaller. If you ever forget, I like to think of it as an alligator. So the alligator goes towards the bigger side. So if num is smaller than 100, I'm going to add my colon at the end, click enter. It's going to be indented for me. You have to make sure that any code inside an if statement is indented. So as soon as I go backspace, if I type code here, it's no longer in the if statement. So we have to make sure it's indented and it does it for you. So if num smaller than 100, colon, and I'm going to do a simple print statement. Print, we're going to print this number is small, else never needs a condition. So we have to make sure else, I see some students go like this underneath. This is not correct. We want to make sure that else is on the same line. So on the same line as the previous if statement. So else print, this number is big. This number is big. So in this case, who can tell me which of these two statements should be printed to the console? The first one or the second one? Jaden, what do you think? Which statement will be printed when I click run?
This number is big.
This number is big, exactly. If I click run right now, we'll see this number is big. Great job. Does anybody have any questions as to how we write if statements? No? Great, okay. So we're going to do the rest of the questions. So take some time, make sure you're not touching the code that says do not touch this code. We're gonna try to do all of these within 5 minutes. And then you guys will help me with each question. So I'll give you guys a couple minutes. If you have any questions, raise your hand or just let me know and I will be happy to help you. Yes, Ryan, do you have a question?
Yes. Which question should I do?
So just do all of them. So we're going to do all of them right now. So we did the first one together. So if you guys want to just redo it, I guess you can. But we're going to do all the questions. So there's only 5 questions in here. So we're going to do every single one of them. And then we're going to take them up together. So that way you guys have a lot of practice.
I have a question about number 3.
Yes.
I don't know what eating cake has to do with tired.
Oh, that is my fault. I forgot to change it. I like cake. Good catch. So I'm going to create another variable. I like cake. So I'm going to go into all of your files and I'm quickly going to change that. Good catch. I like cake. True. We're going to change it to I like cake. I'm going to change it in all of your files. So it should be I like cake. Like cake. Beautiful. I like cake. Okay, perfect. Okay. That should be good. So if you're done, you can raise your hand if you're done every single one of the questions so that I know.
Mine third question still says tired.
Oh, okay. Maybe I forgot to change it. Okay, here we go. I like cake. There we go. So if you guys click, the run button won't work right now because it only runs a single file. So we're going to run it after. I might actually create separate links for all of you. That way you can actually run the code because it only allows you to run one file at a time. How is everybody doing? Are you guys almost done? I know there's quite a few questions. Great job, everybody. I'm checking in on everyone. Everyone is doing great so far. Perfect. Great job. Okay. Looks like everybody's pretty much done up to 3 so far, so that's a great sign. So if you're around question number 3, that's a good thing. Beautiful job, everybody. So far, so good.
My computer just died.
I'm done.
Kathy's done. Whose computer died? Austin?
Yeah, my computer just died, so I just plugged it back in. So can you like send the link again, please?
Yes, of course, I can do that. Chat. Here you go. Just sent it. Okay, so Kathy's done. See how everybody else is doing. Austin's computer died, so we're gonna give him a couple more minutes. Kathy said she's done. Great. Franklin, you're doing a great job. Jayden is doing a great job. Nathan is doing a great job. Ryan is doing a great job. Looks like we're all doing a great job. So around in a couple minutes, at 7:25, we're gonna start taking it up.
You mean 6:25?
Oh yes, I forget that we're all from different locations. So yes. So in 2 minutes, I'll be more specific. In 2 minutes, we're going to start taking the questions up. Does everybody feel like the difficulty is good? It's not too easy, not too hard. I feel like the good questions are good. Awesome. Okay, let's start taking it up. Who would like to volunteer for me to go into their file and take a look at question number 2, and we're going to take a look at it. Has anybody done question 2? Kathy, would you like for us to take a look at your question 2?
Sure.
Great, okay, let's go into Kathy's file. So in this question, we're going to write an if statement. If it is snowing, so we have a variable snowing, it's storing a Boolean, currently it's set to false. So if it is snowing, print I will go skating, else print I will go swimming. So we can take a look over here. If snowing equals true, great job, print I will go skating, else print I will go swimming. Amazing job. I have nothing to add. This looks great. I'm gonna put it into the big main file. I'm gonna rename my file to main. So that will hold all the answers. So I'm just gonna copy and paste Kathy's code, and we can click run over here. I'm going to comment or just leave that there. Main. There we go. I will go swimming. We see that that's printed. Amazing, right? Because snowing is false, so it will print the else statement. Kathy, if I change it to true, which of the 2 statements will be printed to the console?
I will go skating.
Exactly. If I click run right now, we will see it will print I will go skating. Really amazing job, Kathy. Pat on the back. That was a really great job. So that was number 2. Does anybody have questions about how we did that one? No? Jayden, would you like to volunteer to help us with question 3? Yeah? Okay, let's take a look at Jayden. Okay, amazing, we see. So this question, write an if-else statement. If I like to eat cake, print I will eat cake, else print I will eat vegetables. Who here prefers vegetables over cake? Nathan, you don't like cake? Good for you.
I like cake. I just like vegetables more.
Wow, really great job. I wish I was like you, but vegetables are very, very, very good for you. So great job. Okay, let's take a look. I like cake is equal to true. If I like to eat cake. So Jayden, great job, but we're going to use our variable. So you have the right idea, but I like to eat cake, that value is stored inside the variable I like to eat cake. So all we have to do is just replace that. Yeah, just like that. Exactly. And then if statements, lowercase. So another tip, because I always forget too, if it's uppercase or lowercase, how do you remember? If it turns orange, that's a good sign for keywords usually. So if you see now it's orange, so we're gonna make sure it's lowercase. If I like cake, which is our variable, equals true, We're missing something over here at the end. Can anybody tell Jaden what we're missing over here?
Colon.
Colon, good job.
Also, you have to capitalize the true.
Exactly.
Wait,
So
where? Oh, right.
those are like little annoying things that we have to just remember, but you just remember it with time. Beautiful. And I'm gonna remove the spaces. Everything else looks great though. And we don't need a colon over here after the print, right? Print is just a function, so we don't care about the colon. Beautiful job. I'm going to copy and paste this into the main file right over here. Great job, Jaden. We're gonna click run right now. What should I see? I will eat cake. Jaden, what happens if I change this to false?
Print, I will eat vegetables.
Nathan, do you mind just muting? We hear the beautiful piano in the background. Thank you very much. Beautiful, beautiful piano. But yes, here we go. If I like to get true, if I change it to false, it will print. What did you say, Jaden?
I will eat vegetables.
Exactly. If I click run right now, we see that it will print I will eat vegetables. Great job. Who would like to help me with question number 4 who hasn't gone yet? Austin, would you like to help?
Sure.
Great. Go into your file. Number 4. Beautiful. This question, if I like to eat bananas, print I will make banana bread. Else print I will make apple pie. Who here prefers banana bread over apple pie? Yeah, I like banana bread, but apple pie is also very delicious. Okay, let's take a look. If like bananas equals true, print I will make banana bread. Else print I will make apple pie. Beautiful job. I have nothing to add. We remembered all the correct syntax. And I'm going to copy and paste this into here. Austin, which of the two statements should be printed to the console when I click run?
I will make banana bread.
Exactly. And we can see that right over here. I will bake banana bread. What happens if I change this to false?
I will make apple pie.
Exactly. Perfect. Great job. And who hasn't gone yet? Ryan, would you like to help us with question 5?
I'm still working on it.
Oh, okay, no problem. We're going to give Ryan a couple minutes. Franklin, would you like to help us with number 5? I just want to make sure everybody has a turn to go.
Okay, number 5.
Perfect. Perfect. Let's take a look. If it's raining, then print I will wear my rain boots. Else print I will wear my running shoes. So we have our boolean stored in our variable is raining. We're going to say if raining equals true. Okay, so we're missing a couple things. Great start though. You got the core of it down. Nathan, what can I add over here? What am I missing?
An equal sign.
Right, so where you need 2 equal signs. So anytime we want to check for comparisons, remember we did, let me find the slide. Remember we were looking at, where was it? Here it is. Remember we were looking at comparisons. So anytime you want to compare 2 values, a single equal sign, the reason why it won't work is because we use a single equal sign for variable creation. So here Python might think, oh, are you trying to set raining equal to true? No, we want to check for equality. So that's why we're going to use 2 equal signs. And then what else am I missing, Jaden, on this very first line?
The variable is wrong. Like it's supposed to be is underscore raining, but instead Franklin did raining.
Yep, great job. And then we also need a colon at the end of every single if statement. Print, I will wear my rain boots. We also have to make sure we're including circle brackets. So you got the chunk of it, the base of it perfect. It's just a little couple things that we just need to add. So if is raining equals true colon, beautiful job. Print, I will wear my rain boots. And then else has to be on the same line as the if. So I'm going to put the colon after the else, click enter, looks great, and we have to just add the brackets. So for every function, we have to use circle brackets. So I'm going to copy and paste this into the main method. I'm going to put this over here. Franklin, which of the 2 statements should run when I click run? Should be printed to the console. The first one or the second one?
I think you should choose I think it's the first one.
Exactly, right? Because it is raining outside. So it's going to check if it's raining outside, which we see above here. It's true.
It really isn't raining out. It isn't raining outside.
It isn't right now, but let's just pretend it is. I made this question a couple hours ago. It was raining. So let's say it was raining. It's true. So we're checking if it's raining, then I will wear my rain boots. But let's say this question is for now, and I change it to false. Which statement will now be printed to the console? The second one, right? I will wear my running shoes. So we can click run, and we will see. Line 14. What? Oh, is somebody editing the code? No, there we go. I will wear my running shoes. Beautiful job, everybody. Does anybody have any questions about the conditional statements that we just did and worked on? No questions? Okay, great. So if we have no questions, we're going to move on and learn about lists. Can anybody take a guess as to what lists are in programming? Jaden, do you have a guess?
Like a pile of things, like in
Great guess.
list, and then like
Yeah, great guess.
like a regular list.
Yeah, Franklin, what do you think it is? Do you have a guess?
I don't have a guess.
That's okay.
I
That's
have no
perfect.
idea what it means.
You know what it means?
No, I don't.
Okay, that's great. We're going to learn. Austin, do you have a guess as to what lists are?
A group of stuff.
A group of stuff, yeah. So I guess it's kind of in the name itself, but let's take a look. So what's a list in Python? So a list is something where you can store information. So just like a variable, right? It's a similar concept. It's a similar idea. Variables hold pieces of information, but what's the difference? Well, variables can only store one piece of information. So as we took a look over here, if I go back to the code collab, we have is raining is equal to false. That's only one value. We can't give it multiple values for just variables. Whereas lists allow us to hold many different pieces of information. We can store multiple pieces of information at a time. So I'll show you guys what that looks like. But before we get to that, each element or value that's inside of a list is called an item. So we refer to every single thing in a list as an item or an element, both work. Lists are created or defined using square brackets. So this is an example of how we would create a list. My list equals HELLO, and every single item is separated by a comma. So can anybody tell me what the length of this list is? What's the length? How many items do I have in this list? Jada. 5, yeah.
5, yeah, HELLO.
Perfect. 5. That's the length. And that's a function that we're going to learn a little bit later on that we can use on lists. So you might be asking, why are lists needed? Can anybody take a guess as to why lists are useful? We use lists all the time, really. We use lists when we go to the grocery store, right? You write down a list. Imagine you went to the grocery store and you had a separate piece of paper. Let's say you have a paper for only one item. So you would have a piece of paper for every single item. That would be a lot of papers. So it might be useful to create a list to store a bunch of information in one spot. And that's where lists are helpful. Let's say, here's a real life example. Let's say you are a teacher and you want to store the grades of all your students. It's useful to hold a list so that you know all of your students and their grades. Lists can contain any data type, which is also something that we should keep in mind. We can have a list of numbers, so integers. We can have a list of strings. We can have a list of lists. We can have a list of booleans, or we can have a list of all of those things together. So let's watch a quick video. 3 minutes.
When you're planning out your day, brainstorming ideas for a project, or choosing songs for a party, How do you keep track of all your activities, ideas, or songs? You probably write them down in a list. Lists help us stay organized by ordering all the relevant pieces of information, one after the other, in a single place. The same principle applies when we write programs that include many related pieces of information. Variables are useful for keeping track of a single piece of information. But as we collect more and more information, keeping the variables organized can be complicated. For example, what if you wanted to keep track of everybody's name in class or an entire school? It's impractical to create hundreds or thousands of individual variables, and impossible if you don't know how many items should be tracked ahead of time. In JavaScript,
So she's going to talk about JavaScript, but it's the same thing in Python. So just ignore
we
JavaScript.
can keep track of all these things by using an array. An array is an ordered collection of items.
An array is the same thing as list. So if you ever hear array or list, it's the same thing. They're interchangeable.
You can think of an array as a row of numbered boxes. Each box can have one item in it. Arrays can hold all types of data: numbers, strings, and even other arrays. Let's see how you could use an array to keep track of the names of people in a group. In JavaScript, an array of strings looks like this. Notice that all the items in the array are separated by commas, and the entire array is in brackets. Just like how you can assign a number or a string to a variable, like var x gets 5, you can also assign an array to a variable to use it later, like this. Every time you make a new array, you'll want to assign it to a variable so that you can find it again. Your array can be as long as you want. Just use the arrow keys on the side of the block to make it longer or shorter. To access an individual item from your array, write out the name of the array and the number of the box you want to access, like this. This means give me the item in the list names sitting in slot number 2. The official term for slot number 2 is index. You might have noticed that the first index in the array is 0. In programming, we usually start counting at 0, which means that names at index 0 is the first item of the array, and names at index 2 is actually the third item in the array. When your program runs, the computer will look up the current value that lives at the given index of the array, just like the computer looks up the current value of a variable. Arrays are a very powerful way to write programs that use large amounts of data. They open the door for us to write programs that use and process lots and lots of information, especially when we don't know ahead of time just how much information needs to be stored. Let's try them out.
Oh, okay, so that was a really short video. She explained what arrays are. Arrays and lists are the same thing. I use the term lists, but if you hear either or, they mean the same thing. And she spoke a little bit about JavaScript, but it's essentially the same thing. So let's take a look at some examples. So here are a bunch of examples of different lists. So the way that we would create a list is the same way that we would create a variable. There's only a few couple differences. So we start off by giving our list a name. So in this case, I named this list letters. I just give it a name, just like a variable. Equals, and then I use square brackets to indicate that I'm creating a list. And then I separate each element with a comma. So in this case, I have a list of letters. So A, B, C, D. So in this list, I have 4 items or 4 elements. The next one, numbers. You can have a list of numbers. You can have a list of booleans. You can have a list of floats. You can have a random list of all of the data types combined. So in other languages, you cannot, so I believe in JavaScript, you cannot mix the data types in the list, but in Python, that's okay. So you can mix different data types in a list. So let's do an exercise. So if I create my list and I set it equal to 1, 2, 3, if I try to print my list, what do you think will happen? Can anybody take a guess? There's no right or wrong. Jaden, what do you think is going to happen?
It's gonna print 1, 2, 3.
Yes, oops, I clicked it accidentally. But yes, it's going to print 1, 2, 3. That's how we created it. It's going to print it to our console. Great job, Jaden. Another thing that was mentioned in the video was indexing. So computer scientists like to start counting from 0, which is a little bit funky sometimes when you start off learning about coding, but it's actually quite easier. So when we say what element is at index 0, it's actually the first element. So the 0th index actually represents the first element. So we would say A is at index 0. This is just how we would say it out loud. I would say B is at index 1, C is at index 2, D is at index 3. But in total, I have 4 elements. So that's just something to know. So we can use indexing to access certain parts of our list. And I'll show you how we can do that. So let's say I have my list is equal to 1, 2, 3. And I try to print the value that's stored at index 100. Can anybody take a guess as to what's going to happen? Kathy, what do you think is going to happen?
I don't get what the 100 part is.
So this is the process of indexing. So we'll take a look at more examples, but I'm currently saying, what is the 100th index? What item is at the 100th index? So if let's say I were to go to this example, let's say I have this random list. If I wanted to access the second item, so hello, I would say random at index 1, right? Because we start counting at 0. So 1.1 is at index 0. Hello is at index 1. True is at index 2, and so on and so on. So if I were to come to this question over here, oh, I keep going forward. If I were to say 1, 2, 3, what element is at position 100, index 100? What do you think will be printed?
99.
So, but there's no 99. Our list only has 1, 2, 3.
So does it keep on going over 1, 2, 3, 1, 2, 3, 1, 2, 3?
That's a great guess, but actually Python's going to give you an error. It's going to say 100th index doesn't exist. It's like me telling you I have a list of groceries. I only have 3 items on my grocery list. What is the 100th item? You're going to be like, well, there's no 100th item. I only have 3 items, right? So that's the same thing that Python is doing over here. So it's going to tell you what? There's no 100th element. There's no 100th index. There's only 3 elements. Does that make sense with everybody? Thumbs up. We're good? Awesome, great. Let's take a look at another example. Ryan, would you like to help me out with this question? I'll help you out. So
Okay.
I'll give you a diagram. So this diagram is very, very helpful. So, okay, there we go. I have a string list. String list has letter P as the first element, R, O, B, E. So this is the process of indexing. If I try to say print string list, I'm trying to access the 0th index. What letter is at the 0th index? And you can use the diagram at the bottom.
P.
Exactly, P. Perfect, P. P is at the 0th index. Nathan, what letter is at the 4th index?
E.
Exactly, E. Perfect. And then Austin, what letter is at the -5th index? So we haven't spoken about this, but we can do negative indices as well.
I think P.
You can't see? Or
No,
what's
I think it's P.
P? Yes, sorry, I didn't hear you. P, exactly. So we can actually go backwards as well. So if you ever want to access the last letter, this is useful for when, oh, I think I see someone typing in the chat. Class is almost over. Yes, class is almost over. We have 4 more minutes. Yes, as I was saying, we can also go backwards. So if you ever don't know, let's say the length of your list, you can just do negative indexes. Let's say you want to get the last element. You can just do -1, and that's going to give you the last element. Length of list. So we also have a function to get the length of the list, which is very, very helpful. And this is what it looks like. Let's say I have a letters list, which is equal to A, B, C. If I want to get the length, how many elements do I have? I can use the len function. So just like the print function, len is also another function that we can use. And the way that we use it, len, and then we put circle brackets and the list inside of the circle brackets, and that will return the length. And who can tell me the length of this list? Franklin, what's the length of this list over here?
Okay. One of the lists
How many do I have? How many things do I have in my list?
is A, B, and C are just 3 letters.
Okay, just 3. Okay, so that's what length would return. It would return 3 letters. Beautiful. Let's do another exercise. This might be our last exercise. So, Ryan, you're gonna help me out.
Wait, isn't it 2? Because you said the 0 counts.
So that is a great question. Indexing and length is 2 different things. So that's something that a lot of students get mixed up. Indexing, I would say the length of my list, the amount of things that I have in my list, the items is 3. I have 3 items. I have A, B, C. But I have indexes going up until 2. So A is at index 0, B is at index 1, and C is at index 2. So they're 2 different things. So we don't really try to mix those 2. Does that make sense, Kathy?
Yeah.
Okay, great. So they're 2 different things. Okay, let's take a look at this exercise. Let's say I have my list is equal to 1, 2, 3, and I try to print the length of my list. Nathan, what will be printed to the console?
3. 3.
3, exactly. Yes, 3, perfect. So we see 3. Let's say I have a letters list. Ryan, help me out with this one. What is the length of this list?
4.
4. How many letters are there? There's A, B, C, D, E.
5, because A is 0.
So no. We're not going to mix those 2. So I know it's a little bit confusing, but indexing is completely separate from the length. So when I say length, I want to know how many things do I have in my list. So I have 1, 2, 3, 4, 5 things in my list. But the indexes are a completely separate concept. Indexes is for when we want to access. So we start counting at 0 for when we want to do indexing. So A is at position 0. It's at index 0, but I still have 5 items. Okay, let's do one more exercise. Let's say I have new list is equal to 76543. If I try to print my new list, we've already done this, it's just going to print it. We'll actually leave this exercise for next class because that one's going to take a little bit of time. So those are lists. Before we wrap up, because we have about a minute left, does anybody have any questions about anything that we did today before we end class? No? Okay, great. So on the Google Classroom, I will post right after class the review sheet for lists, and I will also post homework that we will take up next class. Sounds good, everyone?